Uh, Good afternoon, Prof. Riri. Let me introduce myself. My name is Fauzan Farasaki Budiandir from Group 12, CLB Track Lab. Today, in this video, I will demonstrate our project, our latest project. So, I will start from the hardware first. So, since Mirza didn't brought his hardware to vacation, so I only gave his run photos. So as you can see from this is from the hardware we using C++. As you can see, this is a success connecting to my versal, which is the HTTP. We have two um, ESP32. First is oscilloscope with identified as oscilloscope, and the second one is multimeter, which is complete. Then it will give a config uh, daftar asset or asset to scanner. Then it will give a boot to Versal, which is the HTTP, and it will give a success. This is a gateway. It's ready to give the data. This is waiting for config. This is for waiting to get uh, the oscilloscope RSSI and oscilloscope and multimeter RSSI, which is the approximation location from the computer, or sorry, from the ESP32 location. This is the detection. As you can see, it has a sorry we don't use sorry we use RSSI, which and in dBm. This is the approximation. The minus is so if you know Cartesius, there's a minus region and a plus region. So this is the approximation where uh, the location is to go. Always is uh, the object locate, and this is change the condition, which is if it's connected and it is uh, in the laboratory. We will it will give in the laboratory or di tempat. Then it will go to the queue and will be processed. And that's it for, oh sorry, this is uh, for the missing, sorry, this is for the missing. This is when RSS, if the object is missing, then it will give a missing condition. So I will demonstrate, sorry. Okay, so as you can see, the total asset is currently 2. One is missing from this photo, and the next one is multimeter. See, you can see this is the assets. So this is for the report of missing. So they will be shown here, and this is the last, also in the last scene too. And this is the edit asset. Of course, we can also add the category, of course. So this is the category, the name, the status, and this is the request. So the request is for as a request is for when you land an object or maybe a laboratory equipment to a user that is maybe a student. So this is for the pending if. So there's a reason. This is for testing reason. This is a requested when and return date when. This is the asset. This is the user. The user is the student or the person who want to borrow. This is the history. So as you can see, the oscilloscope is missing from the period of this time, and this is the notification. This is the function to check if the ASP32, which is the tracker, is connected or missing, or whatever it is in the notification. As you can see from the profile too, there's a role technician, role from user, a role for uh, laboratory member. So this is what I demonstrate is for the technician and the laboratory member. The thing is the same, but it's just the name. So we log out. So we are going to check. Uh, okay, so this is for the user. As you can see, this is a example, and the role is user. The only thing that they can see is they can, for example, request. So as you can see, I already request before this video. Uh, the user, if the user want to see, or maybe want to lend or borrow some laboratory equipment, it need to request to give an acceptance if the laboratory member or the technician accept this. This is the dashboard. So this is uh, the asset that missing and available. So uh, I think this I think this explanation is enough. So thank you, and thank you, Prof. Riri.
Silabi Track Lab final presentation. Silabi is an asset tracker management using IoT to replace traditional error-prone manual logs using ESP32 gateway scanners and BLE beacons attached to lab assets. The system uses an IoT sensor network, database sensor using Neon database and API Node.js, and a real-time dashboard using React. It works by having the Bluetooth tag broadcast a unique ID every 2 seconds. The scanner would then listen for these signals and then apply a timer system and a 300-second timeout. The scan will then find these Bluetooth tags, send the tags that it finds to the gateway, and the gateway will send the data to the database, which is then accessed by the dashboard. The front end is the web interface for the users to view the data. The back end is where the data processing and the logic happens. The hardware is where the scanning and the gateway are installed. This is where in the lab. Data storage is handled by the database, which is Neon database and PostgreSQL. This is the activity graph. A laboratory assistant would log in, and TrackLab would list the devices and the assets. It will then check if the lab equipment is borrowed. If it is, then it will add the data of the borrower. If the lab equipment is returned, if it is, it will remove the borrower. And if the lab equipment is lost, it will then list the missing equipment, their last known date and location. This is for the statistics. The lab assistant will log in again. It will go into the TrackLab statistics. It will then check if the person wants to use AI for statistics. If it does, then the user will ask the AI, and the AI will process the answer based on the data we have. If not, it will check whether the equipment is brand new. If it is new, then it will add the new data, such as the name, date of purchase, and tag. If it's not, then it will show the past data, which is the data it already has. This is the tracking graph. It will check if the device is on and has the signal. If it does, it will give the location every 5 minutes, and if it does not, then it will write the last known location before the device is turned off. It is used by this. If the user wants to borrow, then it will have to enter, and it will update the database and tracking and the statistics. The lab assistants can log in and see this list. These are the class diagram. This is the user sequence. For example, if a user wants to borrow, it would request borrowing. The database will then check whether it is available. It will then confirm if it is ready to borrow, and it will update the database on its own. This is the UI UX. This is the dashboard. This is the asset. This is the user assets. This is the asset requests, and it is used like this. In the asset search, for example, a lab assistant wants to locate a specific microscope. So instead of searching physically for every cabinet, they search the dashboard. That way, they can just find immediately where it is available and what lab it is in. And it can be also used for loss prevention. For example, there is an expensive oscilloscope that is accidentally taken out of the lab. The scanner would then detect the signal loss and waits for 5 minutes to filter out false alarms. Once it is past 5 minutes, it would flag the oscilloscope in the database as missing. That is all. Thank you for your time.